drill into remote workers. Not personally, that would be harsh, but the idea that people are working from home and we need to troubleshoot their lousy internet connections. In fact, for this event, I tweeted some to tell people we were doing it and register and so on. And one of the ideas is I want a way that when that remote worker calls in and has a performance issue, I can look at some data that tells me it's their home Wi-Fi, it's atrocious, or it's their last mile internet connectivity is very poor, dropping a lot of packets or something, so that I have a concrete answer that I can go back to them with and say, hey, it's not us, it's you, and then maybe give them some suggestions about how to improve their home Wi-Fi or something. But how do you figure that out? Is it going back to that agent sitting on an endpoint? Do we have that much insight from that to know what the problem is?
We do, Ethan. I think the one piece of advice I would offer is that you start thinking about that before you have the user on the phone. So certainly you can reactively troubleshoot and get better mean time to innocence with what we'll talk about today. But the best time to deploy is before you need it. So to that end, when you think about the remote worker, you've got the fixed physical offices, and now a lot of those are, the lights are off, at least for a little while longer. But it's worth benchmarking and comparing. I call it really baseline benchmark and compare, where if you have our capabilities deployed via a fixed physical monitoring point at an office or at a data center or both, you have a comparison standpoint there. So you can understand if you've got a user with a problem with, say, Workday, you can look at Workday from those offices, and those are your known good, your reference, your gold standards. Then when you talk about where the users are, you've got to instrument as far out to that edge as you can. And that could take the place of a VM, a container, where you prefer. But most of the time, that is an endpoint instantiated piece of software. Some call it an agent. We call it a workstation or a native monitoring point that can run on Linux, OS X, or Windows. That way, you can understand proactively how the user's capacity, latency, loss, jitter, what QoS changes are happening, the performance of their overlay, underlay, and direct to internet connectivity is. And you can compare that with your gold standards as needed. That helps you understand pretty quickly if you've got a SaaS problem or a last mile ISP problem that's just affecting that user, or maybe the users in that town.
So Adam, here's an important clarification. I've got that that endpoint monitoring that I'm doing, and I can see the segments of the path to know, like, it's their home network that's poor, because look at this section of the graph where that performance is poor. As I get deeper into the path, and I can also see those things, life is good, life is better, life compares well to my baseline measurement that I took.
That's right. And we actually show you a picture of the topology of the path. We discover the topology, we monitor it in real time. We understand the changes that take place over time, whether it's route changes or BGP changes, and we can store that historically for a year. So it's really good for certainly a retrospective, and you can also alert on any KPIs that you see fit. So if you want to understand whenever packet loss is greater than, say, 2% or 5%, or whatever the best practices for your top apps, then you can set those. So the agentry and the service will go off and monitor that 24/7, so you don't have to worry about it. If and when there's something to worry about, you'll get notified via email or trap or northbound notification or an event that's sent to your favorite single pane of glass.
Yeah, and Greg's scenario earlier, so I'm going to my CIO and I know that Oracle's gone sideways every Thursday, 4 o'clock. When did that start? And what changed? Yeah. Applications rarely just start to go sideways on their own. Usually us humans do things. We do change. We try to improve, and in the process of trying to improve, we end up mucking something else up. And so we believe as a platform, we have to give you that 60-second granularity, but we also have to give you 1 year of history so you can go back and understand what's happening over time and understand what changed. And that helps to understand what the root cause is.
So this screen share that just happened might answer one of the questions that just came in. Scott says, I've been on countless Zoom meetings and sometimes the video falters. And during that period, I'll bring up speed test and it's always 85 to 95 megabits per second. So how can I pinpoint where the issue is when the last mile doesn't seem to be the issue? Is it a cloud data center, a Zoom server, a backbone, cloud edge? And maybe we can tie that into the screen share you guys just did.
Yeah, so here's an example. These are two related screens. The first is really the high-level assessment continuously of a single network path, which is responsible for delivering an application to a remote location. This is a location that's proven very problematic over time. We call the ISP. Everything looks okay. We're going to restart your modem. I think you've heard that story before. So this is an intermittent or transient issue specific to data and voice loss. That would affect jitter, that would affect Zoom quality for sure. So we measure very lightweight, non-invasively at regular intervals, every minute. Some of our customers do it more often than that. And then when we detect an issue, let's say packet loss is above a threshold that you define, we'll look at that much more closely for a short period of time to understand if that was a one-time fluke or if it was a real issue you need to get ahead of. So that reduces things like false positives and crying wolf. In this example, you can see my data loss threshold here is set at 5%. That's my horizontal black line. And I can see a number of cases over the last few days where it's handily exceeded. And if you think about 15% packet loss, that'll tank any application. If it's Zoom, you'll drop frames, you'll sound like a Dalek or a chipmunk. If it's a TCP-based application, you're gonna see much longer load times due to retransmits and excessive utilization and so on. So when you get an alert, okay, so I know there's something wrong, it's definitive, and I can clear when the problem resolves. So if my ISP says, oh, we did something, it's okay now, you can trust that, as we all do with our ISPs, but also verify and see the minute that it was fixed and to make sure it really stays that way.
This is really useful for nailing your ISP to the floor. Because ISPs will always say like, oh, it's not us, our network's not showing any problems, or, you know, whatever. If you can come up with statistics like this and say, well, why am I getting 15% packet loss between, you know, as if I look at my analytics and I can see 15% packet loss, that's you, not me. As long as you can make that.
Business values we bring, Greg, is when you have that conversation, whether it's a carrier in the middle or a corporate ISP or residential ISP servicing a work from home user, it, instead of it being an adversarial conversation where the technician on the other side assumes you know nothing and therefore they take you through the unplug your router, plug it back in, when you show up with a set of very fine-grained, accurate metrics like we can show them, the tone of the conversation changes. It's like, oh, there's something going on here. And we hear this time and time again that it's not great to monitor something if you can't actually affect change. And by showing up with a level of granular data we have, those conversations with those third parties change completely to one of, let's go find and fix the problem versus it's not me, you know, reset your router.
Let me give you a story. I know somebody who put an SD-WAN solution in, but he was forced to put it on top of his MPLS provider's backbone. And the analytics that were coming out of his SD-WAN actually proved that the backbone provider of the MPLS was so bad. And they went and had a look at the contracts, and it turns out if they didn't meet the SLA, they actually got refunds. And at the end of the day, the provider actually paid them to leave the network and actually paid for their SD-WAN deployment in the end, because the penalties for not meeting the MPLS SLA was actually more than the cost of deploying the SD-WAN equipment. And in the end, the MPLS provider paid them to quit their contracts because they were providing MPLS free of charge because they couldn't meet the SLAs at all. The backbone was so overloaded, packet loss was so high all the time. So this type of stuff, and that does happen. And this guy's network had been stumbling around for 5 years with this constant pain of performance and outages. And as soon as they put the SD-WAN devices in, it was the analytics that changed the game. And
Greg, we got a comment from Ralph here. He says, as a network services guy, part of it can be the quality of the WAN provider's network. An 8-lane gravel road isn't much faster than a 1-lane gravel road. So,
Bravo, Ralph. Bravo. I'm going to steal that.
It's a great metaphor. I love it. So on this screen share that we're looking at here, we were talking about the fine-grained control. Is that what I'm looking at on the right side of this this screen share, where it looks like we're breaking down the path into multiple hops and segments?
You are. So you can see here hop 1. There was a question earlier about Wi-Fi. How do I know it's my home Wi-Fi or something within the 4 walls of the last mile or the last few feet? In this case, we'll actually discover the topology of the network path from a layer 3 perspective, and then we'll segment the problem to where the packet loss and the latency and all those KPIs are below spec versus where they're okay. So in this case here, I know it's not a problem on the local area network where the user is. So when I send my packets out to the edge, that 0.1, that's my gateway. I'm fine there. So I can get there fine. I don't have a Wi-Fi issue within the four walls of that office. This is an example, a very clear one, of a last mile ISP issue. Now, it often is, if I had $1 for every time I had an outage in my town in the last 3 months that would affect all of us in remote learning, that would be a good story. But it's sometimes a problem further out. Maybe when your ISP peers with another ISP, that may be something that a report like this would educate them. They'll go looking in their internal systems and realize that there is an issue. Maybe it was something in a change control. Lots of things are caused by human intervention that are unattended or unnoticed without the proper tooling and monitoring. So.
And I think here too, one of the interesting things that we're hearing from our customers is that, of course, this is useful data for network engineers. Like, they want to have this data, but sometimes it is the user's environment and they need to prove that. But they want to basically push this data further upstream to the help desk of their organization, make it so that the help desk can access this and have a playbook about this that says, if you see this type of information in the diagnostic, you can go make these recommendations. Perhaps it prevents an escalation to the network team. That's what we're trying to create, some shielding for the network team, create some defense for the network teams, that there is actually steps that can be taken before it is an escalation that goes upstream.
So here's a question from the audience, I think, that gets to the heart of one of the issues of having an agent on an endpoint, particularly with the distributed workforce, with a work from home environment. It revolves around end user privacy and data protection officers. Do you have to deal with the personal data of an endpoint's user, or can you get anonymous data, and would that be sufficient?
Well, see, that's one of the things I was mentioning earlier, is that this can be a really tricky thing when you've instrumented somebody's home machine, or even a BYOD, specifically in those cases too, because we're seeing that as well. There is a little bit of concern around, okay, what data is this? Is it sensitive? Is it user information? So we 100% focus on the statistics that are actually generated by the monitoring point. So this is all just like timing information. It is route information, so we will discover that. And that is the one piece of information that we have to kind of clear with security at the enterprise to say, yes, we can see the user's public IP address that they're coming from. We can see the internal IP address if they're like 192.168 scheme. They have to find out whether or not that either falls within that privacy concern or not, whether or not they're already collecting that via other means, like even in their VPN concentrators or things like that. So that is the conversation, is to make sure that the type of metrics that we have are sound and kind of meeting those compliance requirements. But because we focus on that generated piece, and it's actually not looking at the user traffic, but only things that you control and choose to generate, it is a bit of an easier conversation to have.
If that is deemed risky, and we're very familiar with working with our large customers' data security teams to really assess the risk, and I'd say 95% of our customers would go with our public cloud, where we host everything, and it's easy. It's also very easy to have this delivered entirely within an organization. We call that the private, basically APM private option, where they would deploy one additional thing. It's a virtual machine, and that delivers all the cloud-like infrastructure, and they have entire control and storage and ownership of that data where it is. So that's another deployment option should customers choose to go that way.
We've got a question from Tushar about scale. So if we're monitoring a small number of endpoints and users, great. That's going to be no big deal for any tool to handle. What happens if you got 10,000 remote workers out there? How do you do a deployment in that scenario?
Yeah, I'll touch that for a second. So one of the things I heard mentioned earlier, which goes a little bit to architecture, is the ability to leverage edge compute. And the way our platform's been built, to John's earlier point, the KPIs and the metrics that we're measuring from wherever we're instrumented in the network. It might be in an office at the LAN WAN demarc point. It could be where the actual user is working from in their workstation. In any one of those cases, we leverage an edge compute model with the idea being, let's measure and generate as much of the KPIs locally, so that as you automatically scale the infrastructure, and 10,000 endpoints isn't anything for us. We do that already today. It's thinking about organizations that are going to 50,000, 100,000 is what AppNeta is focused on. By scaling the number of endpoints, we automatically scale the power brought to generating the core metrics. And then it's the centralized analysis that allows us to take that information and bring it together and present it in a way that holds up to what the business needs. And
I
so
think part of the, sorry,
Go
I
ahead.
think part of the issue, getting to the heart of the question is that, is this person, this troubleshooter going to be looking at 10,000 alerts every day? And that's just not feasible.
Hey,
Yeah, and that's how you consume the data is actually really, really interesting. It happens both with the network team as well as the business unit in general. If I think about what's happened in the past 6 months with IT, they went from I'm supporting maybe a couple hundred offices that each had 50 or 100 people in it, and now I'm supporting many tens of thousands of users all from home. And IT, I'm supposed to keep up with that. And so this is where the AI engine built into our platform, where our ability to understand exactly what's actionable and what isn't, absolutely starts to really show its value, because we only want to surface the impactful events, not all the events. We don't want to be another yapping dog in the night.
So this is where remember I talked about synthetic monitoring 20 years ago? This is where they fell down, right? They were pretty dumb. You'd run the tests and the idea of an alert was a threshold, and I spent an awful lot of time thinking about thresholds and what's a valid threshold, but you're starting to apply, things have moved on. So you're saying you're starting to bring software tools to the process so that the old idea of thresholds or alerts is actually somewhat more comprehensive or more intelligent, if you like. Yeah.
Yeah, I mean, notifying someone that there has been a slowdown in the end user response of a 16-step CRM login is good to know. That might be interesting to know that every Friday, because I have 500 users doing it, that my CRM is slower. I might want to see that because that might be progressing towards a threshold that actually breaks the business at some point in the future. So we trend that. But whether you actually want to alert and take an action proactively on that is based upon both the history, what's been happening in the past, applying some baselines to understand, is it a time of day, day of week of month? Is it correlating with underlying network metrics? Because as John explained earlier, we tie the synthetics with the layer 3 network performance. Are they coalescing around the same thing? And so you have to bring all this together. And of course, when you determine there is a problem, that screenshot that Adam showed before, that's an example of our AI engine to be able to go in and do automatic root cause to say, look, this is really happening and this is impactful and you need to take action. Other than that, you want to know what's happened because you want to go back in history, but our job is to only surface the things that IT really needs to take action on.
Another scale question, which is, okay, we just talked about huge scale doing this massively, servicing very large organizations. Does that mean if I'm a small company, AppNeta is a little rich for my budget?
That's a great question. We really are designed around the idea of organizations that are looking at location counts, probably in the order of 20 to 25 locations and up. If you're an organization and you've got 2 or 3 locations and you want to understand the performance, we've got dimensions with our workstation monitoring that might fit your platform. But in general, we're focusing on the businesses that are 25 to 30 locations and up from there.
Yeah.
Another practical ops question from Chris. He says, I'm not sure installing a monitoring node on every remote worker workstation is practical. What about a browser plugin that you could install easily and then activate when you need it?
Well, actually, I did want to talk about this anyway, because we talked about large scale and having lots of data. And of course, we're talking about like a sea of metrics. So it does depend a little bit on what you're trying to action on, but also just thinking about more tactically why you choose to deploy can start bring some focus on the scope of that deployment. And this is something that we're engaging with now in conversations when we work with customers, is to say, well, what problem do you need to actually go solve? And so from a remote worker standpoint, I kind of think of this as a crawl, walk, run. The crawl is you've got some really acute pain. Sometimes this happens with like a VIP group, a group of VIP users. And if the VIP user is having a bad experience, it creates a lot of churn. There's obviously a lot of kind of swarm calls to go solve that, and you're using a lot of man hours to go solve that problem. So your initial scope might be VIP users. It might be to troubleshoot that and maintain sort of performance levels for that group. And that could be a group of users that already have dedicated internet that's being provided by the enterprise, things of that nature, more things under your control. That's the crawl. The walk might be to say, well, we've actually got this business unit of call center agents or a business unit of traders. And it is so critical that they don't have any performance issues because our customer satisfaction is tied to it, or there's obviously revenue tied to it. So we need to measure 100% of those, but that doesn't necessarily mean 100% of the business. You might take this by business unit approach. And then finally, the run might be getting to a point where you have this turned on everywhere, or if not that, at least some kind of representation geographically or by business unit around, around the globe or by county or wherever it might be, so that you have a good mix of understanding of how applications are being delivered by ISPs that are being used by your customers in particular parts of the world, so you can see how the application is being delivered. So it might not be 100% coverage. It just depends on the type of data that you need to support the business for that.
So John, I'm going to be mean to you because you managed to not answer Chris's question. We got the crawl, walk, run. That was good. Actually, that was well said. But to speak to Chris's question directly, he was just talking about, maybe I don't want to put an agent out on every workstation. Can I do it via browser plugin? Is that a delivery method? That's an option? Will we get to that run stage?
Right. So fair enough. I didn't answer the question, which was true. I didn't mean for full evasion. But the reality is
we are truth policers here.
Check.
All right, hold me accountable. So it's not delivered via the browser. So I should answer that pretty transparently. But we do find that the majority of times when we're talking about deployment of any scale, it is being managed via SCOM or something like that. So it is a push that's actually happening, completely transparently to the users, and it's managed in that way. Even in that crawl, walk, run phase, this is something where they're just choosing to deploy it strategically without any interaction from the end users.
And I think the really interesting part about that question that came in was about the idea of leave it there, sitting there and be used when necessary. And our platform is definitely designed around doing that. So you absolutely can push this out, to John's point, completely silent to the user. And when needed, you can turn it on. So, you get a little bit into the how without going down the engineering rabbit hole. There are interesting trade-offs of using browser plugins when it comes to the type of visibility you can get. Namely, it tends to be very high order type of metrics. And of course, the performance of the browser and the virtual machine in the browser can inadvertently start to change.
You're only monitoring what's going on in the browser, right? So if you want to monitor voice calls, or if you want to monitor a custom app, or you want to monitor a thin client, you're out of luck, right? It's fairly limited. On the other hand, installing an agent into, say, a Chrome browser does have the flexibility of letting people bring their own computers, and you can ad hoc them into the network and kick, you don't have to suddenly install something and have administrative privileges and blah, blah, blah. But on the other hand, the fidelity of the data source is pretty low because browsers aren't as tightly controlled and accurate as an operating system is. So be careful what you ask for is probably my answer, because if you get it, you might regret it. So
yeah, you brought up a good point, which is think about the question before about Zoom, and I ran speed test, and I'm seeing the bandwidth. Well, they're operating at completely different levels on different types of data on different places in the OSI stack. Of course, the two don't correlate, and that's one of the reasons why we have.
Speed test is not a viable test for anything, because the speed test nodes are around the corner from you. All it does is calculate bandwidth. It doesn't tell you throughput or packet loss. It doesn't tell you latency. It doesn't. So, as a rough rule of thumb, I threw a rock down the well and I heard the noise. So there's a bottom. That's pretty good. That's about the limit of speed test, right?